Routers have a routing table which contains best paths for different destinations. It's like the GPS for the router that tells which way to route the packet. It has the type of route, administrative distance, and metric. But how does a router decide which one is the best if there are multiple ways to get to the destination? Today, I'll show you the exact 3-step process every router runs through every single time. We'll use this topology and focus on the router that has received a packet destined to 10.1.1.6. So let's dive in. Step 1. It checks for the longest prefix match. A packet to 10.1.1.6 might match a /8, /16, and a /24 in the table. But the router always picks the most specific route, which is the /24. This rule beats everything else. Only if there's a tie on the prefix length does the router move on. Step 2. If different protocols, for example OSPF and EIGRP, offer the same prefix, the router checks administrative distance, also known as AD. It is a trust score, and the lower AD wins. In this case, EIGRP's 90 is better than OSPF's 110. Not because it's faster, but it's just more trusted by default. AD is local to the router, and these are the default values on a Cisco device. If AD ties, which happens if the same protocol have two paths, it will go to step 3. The router compares the metric, which is the protocol's internal math. In this topology, EIGRP will calculate it based on bandwidth and delay. Lowest metric wins. And if everything ties, the router load balances across both paths. That's equal cost multipath, also known as CCNP. So the full order is: first, the router checks for the longest prefix match. Then the lowest admin distance. Then the lowest metric. If they are all tied, the router will do ECMP. Memorize that order and you can explain any routing table you'll ever see. That's it for this video. Like and subscribe for more networking videos. See you next time.